My name is Meredith.
And I'm Coley.
And we're the education team here. And we're so excited to be bringing you these activities about project-based learning that have no supplies needed, or very, very little in terms of supplies, things we know that you have. So this week we're talking about some engineering projects that you can do using only paper or cardstock. So the first one we're going to talk about is building some bridges. And we're going to be building bridges, a couple different kinds using paper. So all you need for this activity is something to give some height to your bridge. This could be blocks. I've used books. I thought you would probably have books. You could use shoe boxes. You could, whatever you want to use. You can use just something to give some height. So you need books to give height. You need some pieces of paper, and you need some form of weights for your bridges, whether that's coins or, I don't know, binder clips or buttons or polar bears, whatever you want to use to give your bridge some weight. So we're going to be building 4 different kinds of bridges using paper. And you can give the students, I'll give you a printout of the different kinds of bridges and how to make them. So you could show the students these bridges right away and say, these are the 4 bridges we're building. And then have them hypothesize, say which one is going to hold the most weight and why do you think that? And once they've kind of given a guess of which one they think will hold weight and why they think it'll hold the most weight, they can start experimenting. So it's also a good time to talk about some variables when you're doing this experiment. So things that we're going to keep the same is the height of the bridges and how far apart our 2 supports are. So mine are, when I tested it, about 6.5 inches apart, and the height is the height of these books. So that's the height that I'm going to keep consistent through all my bridge trials. So the first bridge is just one piece of cardstock, whoop, right across my pile of books. So then I'm going to put some weights on. I'll start using coins. Ooh, but it's already slacking, so maybe this is not the best bridge. Oh, okay. So that bridge obviously is not working. It's not very well supported. That only had like 21 cents on it. So the next one we're going to try is an arch bridge. So this one has an arch here in between the supports, and then my same piece of paper on top. Let's get our 21 cents back on there. Oh yeah.
You can reinforce counting and measuring.
Exactly.
Too.
And even counting money.
Yeah, if you're working on counting money with your students, it's a good way to reinforce that.
Yeah, so this one is obviously going to do a lot better because it has that support underneath. I'm going to put all my money in there. Yeah, so this one, obviously, maybe we can even get a polar bear on there.
Whoa!
Whoa!
I bet we could get another
you
polar
think so?
bear on there.
Whoa!
Whoa!
Okay,
Sorry.
so 3 polar bears and however
Too
much
much
money I had in my bag this one is how much. Oh, then it pops back up. That was funny. Okay, so the next bridge is a bridge that has sides. So this one, we'll see if we get more money, and then you can ask why. How is it different than that first bridge that was just a piece of paper? Why does this one work a bit better?
And if you have a group working in partners to do this,
Yeah.
you could have the kids have a little chart where they write, maybe the chart already has the type of bridge, and they write how much money or weight went on it. If it's blocks, it's 10 blocks. If it's money and you want them to actually count out, 21 cents or $1.
So this one, yeah, holds a lot more. So then they're just, and then as a wrap up, you can say, why did, almost all of my weights. 4 polar bears, that's pretty good. So the last one is a bridge with a corrugated top. So it's this same basic bridge, and it has this corrugated bridge on top, and you're trying to see how much you fit in. And actually I haven't tried this one in a long time. I can't remember if it, I think because you can spread it out, it works a little bit better, but overall I'm not that impressed by the corrugated bridge. Like this one might be a little disappointing. Yeah.
Okay. Didn't even hold any
No polar bears. Well, money. So
you can kind of tie this back to what, why people build bridges, what they might need them for, and what kind of bridge you might build based on the needs for that.
Exactly. Yeah, there's a lot of different things you can get into, even if you're doing a history lesson on, the Roman Empire, talk about the bridges that they built and, how they built them and why, and why they were so strong and why they still have them today to look at, which is pretty cool. All right, I'm gonna leave my pile of money there, because why not? Our next paper engineering project, same idea, 3 structures. This time it's one piece of paper that you're making into 3 different shapes. So I have a circle, and a triangle, and a square, and these are towers. And we're going to see how much weight different shapes can hold. So again, you can have the students make these shapes, which is not super easy to get the folds right to make these shapes. So you might want to have a photocopy you do with the lines maybe drawn on it and then photocopy it onto paper, just to avoid some frustration right off the bat. But then they're guessing which shape they think is going to hold the most weight. And the weights that we're going to use for these are books. I know. So I'm going to, again, you can have a piece of paper, guess how many books your circle shape is going to hold, and then how many books did it actually hold. This always surprises me that it can even hold one. I don't know if we want to do the whole thing and see it topple and see me scream and get scared.
Whoa.
I know, it's pretty impressive. So this could go on for a while. It's going to be surprising for them that this shape can hold, and they can keep going until it collapses, which is obviously very exciting. So the same thing with your other shapes.
And also this paper is has some weight. It's cardstock.
So you could do it with regular paper to make it hold a little bit less.
And you can compare
make the activity. Oh yeah, you could do 2 different ones. Yeah.
Oh.
I know. So if I remember correctly, the triangle ends up holding the most weight out of the 3. And then you can talk about why a triangle is the strongest shape and why you see this shape so much in building and engineering. It's because it's the strongest shape. I would assume they're going to guess the square, and I believe the square is actually the weakest. It doesn't hold as many books, and I think it's because it has all these angles and it's just ending up falling apart. But you can experiment with your students and let us know what you find with this experiment, because I've done it, but it was a while ago. But I do believe the triangle ends up being the strongest because it is the strongest shape, and they probably won't guess that. Yeah, so it's a fun one, and you can, again, like Coley said, do it with normal printer paper and then do it with cardstock and compare how that changes. You could do shorter towers, taller towers, different kinds of books, different kinds of weights, and just play with that and see how it goes.